Is your favorite color the exact same type of data as your height? And why do computers treat them so completely differently?
Think about it for just a second. Like, can you add two blues together to get some sort of math average? Nope, absolutely not, because not all data is exactly the same.
Today, we're going on an awesome discovery journey to find out exactly how computers, scientists, and even your teachers organize everyday information into four main types of data. Once you know these, I promise you're going to start spotting them absolutely everywhere.
Section 1. Numbers or labels.
So, imagine you're organizing a massive box of colored crayons. And then, imagine you're keeping score at a football match. You definitely wouldn't use the same method for both, right? Well, first up, we have categorical data. This is data grouped into categories, or labels, instead of numbers. Think about sorting your bedroom wardrobe into school uniforms and sports clothes. Whenever you sort things into groups using words, you're using categorical data.
Think about everyday things, like your favorite fruit, your eye color, your schoolhouse, blood groups, or even what types of pets you have. Look really closely at those. Notice anything? None of these examples use numbers. So here's a super simple memory trick to lock this in. Name it, label it, group it. That's categorical data.
But wait, what happens when your teacher asks for your age, your height, or maybe how many books you read this month? You don't answer with a word, you answer with a number. And this brings us to our second big family, numerical data. Simply put, this is data represented using numbers that can be counted or measured.
Take a giant test score, like 92. Numbers like this help us actually calculate things, like finding a class average or figuring out who got the absolute highest mark. Basically, if you can use it in a math calculation, it belongs right here. Just remember, count it, measure it, it's numerical data.
This brilliantly shows the difference between our two main families side by side. Numerical data uses numbers for calculations, while categorical data uses labels to organize groups. So let's test this out. Shout your answer right at the screen. Does 35 degrees Celsius belong with numerical or categorical? Well, if you said numerical, you totally nailed it.
Section 2. Counting or measuring.
So it turns out numerical data actually has twin siblings. One twin is for counting and the other is for measuring. Let me ask you a very important question. Are all numbers exactly the same? Like, can you count half a student in your classroom? No way. That would be super weird. And it leads us perfectly to our first numerical twin.
Meet discrete data. This is numerical data that can be counted and is almost always represented by whole numbers. The really crucial point here is that discrete means separate or distinct. It's exactly like counting whole apples in a basket. 1, 2, 3. You count them separately, one by one.
Consider everyday examples like 32 students, 8 pencils, or 3 goals. Do you notice what's missing there? There are absolutely no decimal points. You don't score 3.5 goals in a football match, right? So your golden rule here is count it one by one, and it's discrete data.
Now, let's meet the other twin, continuous data. This is numerical data that is measured, and it can take any value within a range, including decimals. So unlike counting whole objects, imagine filling up a water bottle. You don't just magically jump from 250 milliliters to 251. You pour continuously, hitting 250.5 or 250.75 along the way. You are measuring without stopping.
Take an exact height, like 145.8 centimeters. Continuous data loves precise measurements in decimal points. Things like your weight, the temperature outside, or the exact time it takes to run a race. These are all continuous data, because you actually need an instrument, like a ruler or a stopwatch, to measure them. So, whenever you see a number and you're just not sure which twin it is, ask yourself loudly, did I count it or did I measure it? If you counted separate things like books or goals, it's discrete. But if you used a tool to measure it and it could totally have a decimal, it's continuous.
Section 3. The Big Data Summary.
Let's bring all of our amazing discoveries together into one giant cheat sheet that'll instantly make you a data expert. Let's walk through this map together. The golden rules are right here. Numerical equals numbers, categorical equals categories, and within numbers, discrete equals count, and continuous equals measure. If you ever get stuck, just ask yourself, count or measure, name or number, and you'll find the exact answer.
Section 4. The Ultimate Data Challenge.
Okay, it is game time. Get ready to pause this explainer if you need extra time and just shout out the answers.
Challenge number 1. Which type of data describes your favorite fruit? Think about it. Is this a number or a category?
It's categorical data. Brilliant job if you got that right. It uses labels, not numbers. Remember, you literally can't add an apple and a mango together to get a mathematical average.
Okay, challenge 2. True or false? Discrete data is usually measured rather than counted. Think back to our apples in a basket and the whole numbers rule. False. It's continuous data that gets measured. Discrete data is counted one by one. Measuring temperature or height is continuous, while counting discrete goals in football uses whole numbers. You guys are getting so good at this for sure.
Now I have a very special mission for you. I challenge you to become data detectives in your own homes today. Look around, write down 10 examples of data, like the number of chairs, the color of your walls, or the temperature on the thermostat, and classify each one using our 4 data types.
You can now recognize and compare all the main types of data. But this leaves us with a massive question. Now that we know the different types of data, how do scientists, teachers, and researchers collect the right data? In the next explainer, we'll learn how to plan and collect data like real data scientists. See you there.